Okay, we're back again live. Here I am again, and here is Winston Jenks, who is going to tell you about his really exciting software, VPLink. I think you're going to like this one. So I'm just going to see if people are joining us. So I can see we've got 39 people joined already. And if somebody could just type in the chat and tell us, yeah, hello, Jim. Yes, we can see you. You can see us. And hopefully we're coming over nice and clear. Yep, Tom and Arthur can see us. Yep. Very good. Okay, great. Wonderful. I'm going to hand you over to Winston then. And let's see what he's got to tell us.
Okay. All right. Well, thank you very much, Heather. I'm actually very excited to do this for the first time at the LiveCode global event. But I guess we'll just jump right in. So let's take. All right. So what I'm going to talk about today is really how we've leveraged LiveCode and its predecessors for a number of years. We have a slightly different delivery model, I think, than perhaps the typical LiveCode user. So we'll go over that and how that impacts what we're able to deliver. But first, I guess we'll start off with a little quick introduction and a little bit of history. So my name is Winston Jenks, and I'm the technical director here at Cape Software. I've had the same title for about 27 years now. The company was started back in roughly 1990 when I had the same job back then. So anyway, we'll talk a little bit. So we have one product here at Cape Software, and it's called VPLink. And the idea is that it's used to test automation systems before they're actually go online to control a particular process or whatever it is. So you can imagine that there's lots of refineries and sort of chemical plants that are sort of obvious applications for someone with a chemical engineering background like myself. But there's also lots of other applications for automation where people want to make sure that the automation works right. So even as simple as a crane or an elevator, traffic lights as well. These are all things that in the 21st century are pretty much all controlled by small programmable logic controllers. And the key thing there is that all of these little controllers and automation systems, some large, some small, they're all intended to perform certain actions automatically, and especially when something goes wrong with the facility. Then they're supposed to typically take action to keep the people and the equipment safe in there. But like many things that are automated, there's still a human that's somewhere in the loop, right? So people still need to program these things. And of course, large, complicated systems, the only question is not, will you make a mistake, but, can you find the mistakes that you've made? So the purpose of the VPLink software is really to perform as a simulator. And if someone is, for example, putting together a new facility to make beer, for instance, then they'll want to test that before they actually go online. Because while making beer is not necessarily as dangerous as doing some other things, nobody likes to waste beer. So The interesting thing about making beer actually is that the pipes get cleaned out periodically to make sure that there's no sort of microbes or any growth that actually gets stuck in the pipe. And they clean the beer out with a fairly caustic chemical, which you don't want to mix with the beer. So because it's possible to, we want the beer to flow today, and then after that batch is done, we want to put the cleaning fluid through, and we don't want to mix the cleaning fluid with the beer. So if you leave a valve open at the wrong time or something like that, you can waste a batch like that. So we provide a simulator that mimics the operation of the facility, so that people can actually start up the facility in a sort of simulated environment. And that way, when we make mistakes, or when we find mistakes in the control logic, then we don't have to, for example, waste any beer in this case. So I'll talk a little bit. Some terminology that we're going to need to get straight is the control system is typically sending output signals to the facility, to the plant, and that would involve opening valves or starting pumps, changing the position of a control valve in order to perhaps control a flow or something like that. And when we hook up the simulation software, the simulator's job is to then send responses back to the controller to make it think it's really connected to the plant. So if the control algorithm opens the valve a little bit, then we'll calculate the flow rate and send that back to the controller and say, now there's 15 liters per minute. And if the target set point is 20 liters per minute, then the controller will continue to open that valve until we send back the right amount. So anyway, back in the previous century, when people were testing these things, a lot of times you would connect up a panel that had some lights and some switches on it. And the controller, of course, would turn on lights that would represent pumps that were starting or valves that were opening. And then there was the job of the poor guy who stood in front of the panel, which was me some of the time, to flip the appropriate switches to mimic the operation in the field. But you can imagine if you have 50 valves that need to be opened or closed in rapid succession, there's no way that the poor human is going to keep up with that. So we really needed to come up with a better way, right? So here's a quick sort of just deep picture of what's going on here. We have the control system on the left that thinks it's running the plant. And then the software on the right-hand side is reading the outputs, figuring out what's going on, and then sending those outputs back. And typically that happens as often as necessary, typically once a second, but can also happen a little quicker for some faster processes, right? So the requirements for the simulation software is, first of all, we need some sort of graphic capability, because the users who are perhaps operators or engineers are used to looking at a graphic that represents their facility. And so the simulator, if we can sort of replicate that graphic capability, that would be a great thing as well. But of course, every project that we do is going to be different. Everybody's going to have different graphics. We're going to need to be able to draw different types of processes and drag the live values onto a different place. And the other thing, of course, is that it's going to need to talk to the automation system. And back in the day when I first started, generally that meant we just need to talk to something over a serial RS-232 link. But now, of course, there's typically almost everything talks Ethernet, various protocols over Ethernet. But we still need to be able to add in some functionality to do that behavior. Right, so when I first started thinking about replacing these light and switch panels, I thought, well, we need a user interface. And in fact, we had just finished up a project for someone else, and I was looking around for a way to rapidly build a sort of mock-up of what the final software might look like, in order to just experiment with how the user interface would work, how we could talk to the automation system in something. So back in the late 80s, I was looking for a prototype software, sort of rapid application development environment, and sure enough, found it.
Winston, can I just interrupt you for a second?
Yes.
At the bottom of your screen, it says something like webinar screen sharing.
Let me just hide that.
There we go. Hide it. That's the one. Off you go.
Okay. So this was right back, I guess, when HyperCard was in its glory, I would say. And we actually built the prototype using HyperCard. And then very quickly, I realized that I was not going to be able to replicate all of that functionality that I had put into the prototype, because it was just too useful, and redoing all that in Mac app was going to be quite the issue, right? So obviously, we're able to draw graphics and build buttons and things like that. Of course, the wonderful scripting language was able to really kickstart us and get us going. And of course, it was extensible as well, with sort of X commands and X functions back in the day. And I could add to the language and do whatever was necessary to talk to the automation system in these little externals. So that's really kind of what got us started there. And the other requirement that we have is that the users like to generally be able to add their own graphics and interact with the simulation as well. So we had to, and of course, the HyperCard application was wonderful at the time. Okay, so the answer that I came up with was we were just going to deliver the prototype as the actual application itself, right? Rather than redoing anything else all over again, we found that actually just useful enough, and we could deliver the prototype. So we actually got started back in 1990 in the company, selling a whole bunch of Macintoshes to industrial customers, most of whom had never seen one at the time. Okay, let's jump back to the future. Now in 2017, I'm happy to say that we still pretty much have the same lineage of the user interface. And you'll notice there are some user interface elements. If I can jump back here real quickly, you'll see at the bottom, there's a couple of buttons and a few checkboxes down there. And those would actually control the state of the simulation. So the leftmost checkbox updates the screen. We actually needed to turn off the screen updates at certain times because the computers just weren't all that fast, and we didn't need to waste time updating the screen if nobody was going to look at it. The button in the middle turns on the main calculations, and then the I/O button would actually then start talking to the controller. And you can see that we have pretty much that same set of buttons here in the existing software now. And I like to say that we're still delivering our prototype. Of course, it lets us change the application very quickly. It's probably doesn't go a month or so without some new feature that gets added into it. And the thing about our delivery model, though, is we don't just use LiveCode to build the application itself and then deliver the application. We actually deliver a copy of LiveCode as the application for all of our users. So all of our users get the full capability of the LiveCode development environment to build their own graphics and really customize the application as they see fit. Now, of course, that means the users get access to everything, and they can go around and click on various buttons and things like that. So we do have to sort of take some precautions to try to be careful so they don't, let's say, break the most important features of the software, so it will still work for them. The switching between let's say the browse tool and the pointer tool is really, we've just simplified with the edit sim button. That's this little slider in the top right that slides back and forth. We'll take a look at that. But really, I think the key functionality is the ability for the LiveCode script to manipulate itself, right? And we draw on this very heavily. We have lots of scripts that will completely redraw the user interface or take a file from some other format and replicate that format within LiveCode by just effectively redrawing it and repopulating it. So this model has actually been very successful for us in terms of how we can deliver changes very quickly to the customer. In 2017 now, we actually have, and I guess this has actually been around for 10 years now, so I shouldn't say just in 2017, but the architecture of the VPLink software has been split up into various components, all of which can talk over the network. So the graphical client is the LiveCode application. And there's a VPLink server, which pretty much just holds a database of all of these simulation tags that we have. And then we need a few other things floating around to be able to actually communicate the values in the database to a particular control system. But I've been very happy in that we've been able to really extend the LiveCode graphical client interface with the externals functionality. And we've put quite a bit of functionality in there. So there's actually the Corba interface is a remote procedure call mechanism, standardized for a while. It's probably not the simplest one to use, but it does work very well in cross-platform applications. And we've been able to take basically the whole client side of our Corba interface and embed that into the LiveCode environment with our little external that we have. We'll get into a live demo here in just a minute or so. I think just a few more slides so we can actually see all of this stuff in action. Right. So one of the things that I want to point out with this demonstration is obviously we can switch between sort of the developer and the runtime interfaces very quickly. There's a few tricks that we have in terms of making various graphics work faster. Of course, the external code is very important for us to actually connect to our external database, which is doing calculations. And we'll talk about how we use this, the thing that we call the VP support stack. And I've got a couple sample user interfaces as well. So what I'll do here is just try to jump back out of here. So Heather, just making sure this screen's still being shared.
Yep, it's all good. I can see you.
Okay. So we have a simple user interface here. And like as I mentioned before, so we're in sort of the runtime or the simulation mode. But with a click of the mode button over here, then the user gets access to the familiar set of tools, including the drawing tools and paint palette, which I believe is just off the screen at the moment. But now, of course, we can manipulate the user interface as you normally would within the developer environment, but switch back to the browse tool, and the user now effectively thinks that he's actually sort of, running the application, which of course he is. But we've just hidden the developer tools and are still just running the same application here. So each tag has, or each simulation has a number of simulation tags. So this little panel, the search panel, queries the database, finds all of the tags that are available there. And when the user needs to adjust or add a new tag, of course, it's just a simple drag and drop for him there. And one of the things that we can do that typically, I mean, this is a small simulation with just probably 14 tags or so. It's not uncommon to have many thousands. The largest simulation we have, I think, is 60,000 tags. But sort of 2,000 to 5,000 is a typical number. And a lot of times we just might want to see all of those tags on a particular page. So there's a command here that we use, this do tag sheet command, which will just take all of the tags in the database and lay them out on the graphic. Now, when we have 14 tags, of course, it just happens immediately. But if we had 5,000 tags or 6,000 tags, this page would get full, and we would actually then need to create a new page and then populate those with all the fields. And what we found is that if you do that, and it's kind of fun to watch the fields, be created, but locking the screen is quickly deemed very appropriate because you get tired of watching the screen being created dynamically after about 10 seconds. But even locking the screen, which helps with the time it takes to create them, is still takes quite a long time for the number of tags we have. So we actually have we've employed, I think, an interesting technique where we will build the new page, but rather than populate all of the tags on the page, we'll just insert a script into that page so that the first time we go to the page, it will then actually then populate the page and lay out all of these tags and these values. So if we end up having to create 50 or so pages, we end up just making the new page and then insert the script so that the first time we go to it, then it'll get drawn and created for the first time. So there's sort of that delay in when we actually do most of the work enables us to speed up the user interface quite a bit from that standpoint. And of course, if I switch to edit mode, then we can take a look at all of the scripts that the user has, or that we've put together. And the idea for how we then actually deliver this is there's what we call the starting point, or the virtual process blank. So there's a blank template that has the major features of the software: the navigation bar, the status bar down at the bottom, and actually, there's sort of a first page that allows people to sort of just get familiar with it when they first open it. But we deliver this VP blank, which becomes the customer's their simulation file, or their project file, as it were. And we would just save that as as a different project name if someone starts a new project in the day. But of course, there's lots of shared items, right, that are used throughout all the different projects. For example, everybody has this search window, right? All the projects have a window that will show the details for a particular tag, right? And there's lots of different utilities that are all common. So when we want to, the problem with delivering a blank application and then having the user customize it is that when he goes to upgrade that application, he may need to upgrade all of his stacks. And so we've tried to take all of the common points out of the actual project stack, and they all end up going in a separate library stack. And that library stack then has all of the common functionality for the bulk configurator or the scenario manager, and all of these sort of typical things that are common to each of the VPLink projects. I believe if I just take a quick look at the stack script, we can probably find, if I could type, we can find, so there's one of the, as we look through the, oh, that's where we're closing the stack. So the link VP3, we end up just down here. There should be a load stack message where we'll bring in the VP support and just turn that into one of the stacks in use. So that's how we can deliver some of the common functionality. Now, we've actually found that the LiveCode scripting engine is very fast, and we can actually generally update the graphics, the values on this graphic, generally faster than the actual control system itself will update graphics. So most control systems these days may update at half a second or a little quicker than that, and it's very easy for us to set our screen update. You see us here, it's 0.2, but we can easily go down to a tenth of a second or even much faster than that to show these values very quickly. Just a little bit on the simulation side, we can see here, I'll play the controller, and as the controller opens up the valve, then you'll see we'll get more flow that goes into the tank. And as the tank level goes up, then there's actually sort of a gravity flow sort of algorithm that's calculating the flow that's leaving the tank. So all these values would be communicated back to the control system, and typically we would do the debugging there. But it's nice to be able to intercept a value. And if we have to, for example, force something that happens in the field that's a result of some sort of equipment failure, we can take care of that. So in this case, I can just close the valve, even though it wasn't commanded to be closed. And at this point, the level will just start to fill up until the operator sees that there's something wrong, and he's about to put beer all over the floor. So he should then take some action to mitigate that. One of the things that we found, I think, somewhat surprising from our work is that this is quite applicable to a variety of industries and different types of processes. So we've had, right now, we actually maintain a training simulator for a consortium of companies called the Marine Well Containment Company. And they actually were formed, if many of you might remember, there was a spill in the Gulf of Mexico a few years back, the Macondo incident. And at the time, it took, sort of well over a month for the, let's say, industry experts to mobilize the equipment to get out to the Gulf of Mexico. And part of that was because, there's sort of different companies involved and so forth. Well, the government got involved after that and pretty much told all of the oil company operators in the Gulf of Mexico that, look, you guys got to figure out a better way to do that, or we're going to figure out a better way to do that. The companies got together, formed this consortium, and now the consortium maintains equipment that's sort of on standby at the ready to be ferried out to wherever in the Gulf of Mexico just a few days after, in case there's another accident. Now, the operation of that equipment, of course, it's hopefully never used, but when it does become used, then we need to put that into service right away. So as part of that requirement, a training simulator was very important to the consortium, and they chose us to actually deliver the training simulator for them. I've got the application, part of that application here. Let's see if I just close these other windows. Here we go. Then, oh, get away. There we go. So they've got. I'll jump over here, and so this is a typical graphic that the instructor would look at, and you can see there's quite a detailed representation of what's going on in the process. But the consortium takes member or operators from the member companies, and they operate sort of like the National Guard does in the U.S., where every 2 weeks out of every year, you will show up for the appropriate training in case you need to perform the role of a National Guardsman. And so the member companies work the same way. They send their operators to the Marine Well Containment offices where we have the simulator running, and they practice running the equipment. Even though, I mean, you can't actually run the equipment because all of the equipment is sitting in a shipyard, not connected to anything, ready to be loaded onto a ship and taken out to the Gulf of Mexico. But with the simulator, the trainees then can actually train on how to use this equipment, so that when it does come to use it, on day 1 or day 2, they're very proficient with how that works. One of the interesting things about the way we developed this interface was, in this particular case, if I switch back to the edit mode, you'll see, this is locked. Let's unlock that. You'll see that what I've done is basically taken a bitmap image from the actual control system, and that's what I'm manipulating here in the background, right? And we take that bitmap image and import that into the software, and then we use a LiveCode script to go interrogate the graphic file in its native format on the control system. These days, that's typically XML or HTML, but we interrogate that to figure out where all of these values that we overlay on top of the value from the bitmap go, and then we can overlay the live values on top of the static bitmap, and of course the LiveCode gives us a way this is somewhat automated for various control systems, so that we can automate taking the snapshot on the control system side, save the bitmap or PNG, and then interrogate the graphic file, and then use the LiveCode script to lay out and manipulate and build our user interface very quickly. So if I page through just some of these, you'll see that there we have lots of different graphics with that particular format.
That's awesome. Can I just interrupt you for a second, Winston?
Sure.
We've got a couple of questions here.
All right.
So first of all, Mikey was asking, what did you do between HyperCard being abandoned and picking up LiveCode? Well, I think I've told him the answer, but you confirm this.
Yeah, so we did actually, we were forced to live on the dark side for a little while, and we used the Toolbook product in the meantime.
Oh, yes.
So Asymmetrics Toolbook, or Asymmetrics, had basically kind of, I think, cloned the functionality of HyperCard, and we used that quite extensively through, let's say, the late 90s, and into 2000. I think they were a very successful company, sort of leveraging that. I know that when we started, we could buy a copy of Toolbook for $200. And when we finally abandoned that and went back to our roots and LiveCode, I think their product was up over 3,000. I think they did make a successful run and still do, I think, as far as I can tell, on the Windows side. But other than some sort of vocabulary differences, anybody that looked at Toolbook would obviously see the HyperCard roots there.
Yeah, we did pick up a few people from Toolbook as well. I remember that now. Yes. So another question here. Hang on. I saw that. So Clarence has asked, Do you keep trend logs so that your user can go back and see what's happened over a given time frame, maybe for troubleshooting?
Yeah, so that's we do have trending functionality. The trending is, of course, built into all the control systems, but we do have a little trending. I call it sort of the poor man's trending. And under the hood, so we just have this sort of graphical interface, which if I locate, I don't have, no, the new machine. Essentially, this is a front end for NuPlot, right? The GNU plot trend builder. And what we do, what this little faceplate does here is the locate finds the version of NuPlot that you have installed on your machine. Of course, I haven't updated this machine with that. But once you do that, then let's see, we can probably actually see that if we take a look here in the script. See if it's in the card script. So there should be, see if there's an update in here. Save trend. Okay, so here's where we're opening NuPlot, hiding the console window, update backgrounds, right? So the way we do that is we essentially open a pipe to NuPlot from LiveCode. And you'll see down here, I'm setting a whole bunch of NuPlot commands, just building those up. And then when we get to the end, this variable, the total command, is all of these commands together, and we just write that to the process, to the NuPlot process, through the normal, pipe functionality of LiveCode. And then NuPlot takes those commands, and then we'll redraw the plotting information. So this update background gets called on a timer, and it gathers the more recent data from the database, puts that into a nice little set of commands. There's probably, I think for each update, there might be 50 or 60 lines with the data for the different trend lines and their colors and little shapes that go with the trend line, and then we just write that over to the NuPlot process, and we do it that way. So yeah, there's a very well-known acronym in the process control industry of OPC, which stands for OLE, for process control. And it was really an attempt to allow different control systems to talk to each other amongst a common standard. So all my process control buddies know OPC as that. But I still like to refer or think of OPC as other people's code. And we're more than happy to leverage some other tools to do that sort of thing. So in this case, NuPlot turns out to be one of the things that we leverage for that sort of thing. I'm sure you've also noticed that we don't have my 8.02 version running here. One of the things that we're especially excited about in the new version is our ability to recreate what we've done with our graphics. So this little valve acts as a certain object. And if we take a look at its script, it just receives by the rest of the VPLink framework a group object update message periodically. And then it's given it has a name associated with that as well. And we just use that name to look up into the database to find the actual value, whether the tag's in manual or automatic, and then use that script to update the value of the tag. Most of the button or the graphic objects that we have here, there's actually even a little graphic object editor. Hang on. That's built in here. Oh, it seems to have gone off the page. Oh, no, I got to get back to sim mode, of course. Tools. Get over there. Oh, so I think, script editor maybe? There we go. The graphics editor is sort of just a built-in tool to actually create groups. And of course, it just relies on the edit group functionality largely from within LiveCode. So that's how we would create different graphic objects then that the user would put out. But in of course the 802 version, that the whole graphics mechanism is we've been looking forward to that rewrite for quite a while now, and we're actually busy trying to make updating all of our graphic libraries and such like that, so we can take advantage of the LiveCode Builder and what we can do with that with the 802. Was there another question, Heather?
Sorry, I had my microphone off. So we do have, Robert said, so you scan the graphic and the LiveCode script finds and populates the proper areas.
Yeah, and mostly that's an exercise in parsing XML or HTML. For some control systems, we'll have a little external helper script. And we, because if it's not really XML that we're parsing, then we may need to bring some other tools to bear, in which case we'll look through its native database and then export an XML file, which has the key information from the other graphics. And then we'll just say, oh, I need a field, for example. If we take a look at this field, right, I need a field called FIC100SP at the appropriate location here, on the graphic. So we'll just encode that or keep that in the XML file. If we can't read it directly from the particular control system, then we'll have a little helper app that makes sort of a standardized XML that the LiveCode will read, and then pretty much redraw the interface from there. I've got we did some work for Rockwell very recently, where they're upgrading from their older controllers to their newer controllers, and we actually put together a parser that looks through the control system, so that for any given output, a pump that's turned on or a valve that's turned on, we can trace back through their logic to find all the inputs that would perhaps be used to influence the value of that output. And then we'll go through, and we've built thousands of pages, based on this parser output, so that we can find every single output in the control system and build a page that has all of the inputs that are associated with that. So that might look like, this would be our template page for that, where you'd have a certain set of outputs and then a whole list of inputs that would represent that. And then very quickly, well, not very quickly if it's a large file, but at least now you have a chance to see what inputs are affecting your outputs, and do a much better quality test of the logic before it goes online. I tell you what, Heather, let me jump out of the demo just a few slides at the end. If there are another questions, we'll have some time to get those. But I just wanted to kind of jump back to my notes real quick to just see what else we had. Let me just we got through that. Just some other samples of actual graphics that we've built for folks. The SRU complex is a sulfur recovery unit. You might be able to tell that's a piece of a refinery. And so we've built a number of sulfur training units for refining customers throughout the U.S. There's a refinery here in Houston, the Lyondell refinery. We pretty much have every single unit in the refinery simulated, so that their people can go through and operate, learn how to operate the facility. Chevron out in California has reduced their emissions. If they sort of make a mistake operating, then maybe a little carbon dioxide or maybe a little benzene might leak into the atmosphere. They've reduced their emissions by a factor of 10 by using the VPLink simulator to have their people handle upset scenarios better than they used to. That was a huge win for them. They're not saving a whole lot of, that's not a sort of direct dollar cost, but for a large company, and I think especially Chevron, the environmental benefits are very, very important to them. We can also build a replica of a local panel. So you can see this was just a photograph of that panel, and we've taken some LiveCode buttons and just kind of laid them on top so that somebody can actually push this. If we're running LiveCode on a touch screen, then the operator can actually push the button on the touch screen just as they would out in the field with the live panel. We build some. This is although this one wasn't automatically built, we do have inside of VPLink a gas flow network, which for computer science people is basically a graph. You have nodes and you have links between those graphs. We use GraphViz to actually lay out the graph automatically and produce documentation of how our process is laid out. But we also use LiveCode to interpret the GraphViz output so that we can automatically lay out these sorts of graphics. And all the pressure nodes are connected to the pipes with all the valves in the right spot with a little help from the GraphViz layout engine. So that's a very interesting tool as well. And so just in order to leave some time for questions, we'll get close to wrapping up here. So what's happened to this little garage outfit, right? I told you I've had the same title for just about 25 or 27 years now. And we really did start off in a garage or, in sort of the back corner of my house. But since then, we have, hundreds of users all over the world. The refinery that's closest to LiveCode headquarters up there near Edinburgh is a very good VPLink user. So we like to think that we're keeping everybody in Edinburgh a little safer as well. So we've worked on offshore assets in the Gulf of Mexico, Western Africa. There's a new training simulator in Brussels for Brussels Energy that's turning waste into electricity. We did a project for NASA. It was just a simulation of a crane, but it's the crane that used to stack solid rocket boosters and move the shuttle around. And my wife liked to call that project the "Don't Drop the Space Shuttle" project. There's been some nuclear work as well. A few years ago, we tested 8 reactors in China, and VPLink was used to test the control logic that drops the rods into the nuclear reactor that causes the scram. So there's lots of duplication there, and the test plan is just absolutely ridiculously complicated, but so is the logic. In 2014, we were acquired by the Wood Group, and now have offices all over the world as well. But I like to tell people when they buy our software, it might be your software, but it's still my baby. I think we have a lot of folks that have been with us for a long time, and being able to really have, I think, one of the most flexible user interfaces in the industry has really helped us keep the world a safer place, one plant at a time. So if you have any more questions, Heather, I'll be happy to take those.
That's fantastic, Winston. Let me see now. I think there was, let's have a look.
Should I switch back to the?
Yeah, come back to the camera so we can see.
We'll come back to the camera here. Yeah. That's here.
Turn off your screen share.
Yeah. Oh yeah. There we go.
There we go. And turn your camera on.
Oh yes. Oh.
There we are.
That was me in Australia at a wildlife park.
Yes. Okay, so you can probably now see the questions there.
In the chat. Yeah. Yes, right.
Okay, so.
Oh, so let's see. Don, very good. Yeah, GraphViz is actually a good tool. That's so awesome, I think. I'm glad Mikey liked that little comment. Yeah, not very much. Okay, so do we integrate with linear programming solvers? The linear programming as it relates to optimization is typically an add-on product that would be used at the control system. which we don't necessarily provide the optimization functionality within VPLink. However, we do use a solver for that liquid network where we have a giant matrix of equations that represent the flow and the pressures there. That turns into basically a big matrix. There's a solver called SuperLu, SuperLU, which is quite useful for that. So it's just a normal solver. We have to add some techniques to do the sort of nonlinear part of it to converge on the solution. But SuperLu's a very nice product, kept maintained very well. I think we started with version 3.1, and I think we're up to version 5 now. The latest version actually allows us to use the multi-threaded or multi-core capability so that we can solve the pieces of the VPLink simulation on different cores now. And I can have different threads handling one matrix and another thread handling a different matrix. So yeah, that's getting down to the guts, but that's a very nice piece of work. I would give lots of kudos to the SuperLu guys. Snapshots of this deck. Let's see. You scan the graphic and LiveCode scripts finds and populates the proper areas. Right, that is correct, Robert. We do. Boy, some of the file formats that aren't, let's say, modern. In terms of HTML, XML, even comma separated is nice sometimes if you can export that. But some of them are very old databases, that really aren't documented, and sort of just fixed length records with a size up front and so forth. So yeah, there's quite a bit of variability there in terms of how we would actually scan through the various graphics.
Yeah.
Let's see. So we talked about the trends there.
All of them, I think. Yeah.
What's the? Oh, right. There was a question there. Yeah, Don. Okay, so the OMG Corba comment deserves a little bit of explanation. I would say that was probably the most difficult remote procedure call method that I've ever run across. However, the particular implementation that we use is used very heavily by the military in its simulation environment, and also is essentially the foundation for Boeing avionics. So if you've been on a Boeing airport, on an airplane, I'm pretty sure you've used up front is the same technology that we use for our client-server communication within VPLink. However, and one last plug on that, the very latest implementation of the latest standard for C++ compilers has made really using C++ just as easy as using any of the .NET languages. So, C#, let's say in particular, in terms of making your remote procedure call client and server interfaces. So if you've been thinking about remote procedure call stuff and it's been a while since you looked at it, take a look at the C++ 11 standard now for that, and that new templating standard makes it a lot easier to do that sort of thing. What else do we have? Oh, am I reading these backwards? I'm probably reading these backwards.
You are, yes, because
you down from the top down. So
yeah. So because the latest ones come in at the top,
and I can see Jim has got
a new question for you.
What was that?
At the top there, Jim has just come in with a new question, which I think is interesting.
Oh, any of your customers want training software on tablets? So yes, in fact. Just be a little sneak preview here. Although we love the LiveCode interface, the 3D interface to VPLink is coming. So people can walk around their simulated plant, and then we can pop up various information on virtual billboards if they click on a valve or whatever to see what's the status of this pump and how that's running. The training software on tablets, we were able to leverage the functionality of LiveCode. So we have not only the Windows client interface, but pretty much the same code builds us our Android interface as well. So you can run the full VPLink client interface. Everything that I showed you there, all that works on Android as well. And you can, use your phone. We didn't build the iOS one, but we do have a Linux version as well, which we just use for the development elves. Actually, we build on Linux just to catch bugs in Windows because we do find more issues. The GCC compiler is a little better, we think, at finding things than the Visual Studio ones are.
Okay, I have to tell you, it's now 7:01.
All right.
So I'm going to have to draw this to a close. I know Ali is waiting anxiously to bring you widgets, bring you your monthly dose of widgets here. And so I'm going to have to very reluctantly end this session. It's really interesting. Thank you, Winston.
Well, you're very welcome. I'll probably stick around maybe I'll stick around for the widgets.
Yeah. Come and see.
So
all right.
Anyway, thank you very much, Heather, for the invitation. Yeah. I really hope everybody enjoyed it as much as I did. And even if you're not in the automation world, maybe there's a few tidbits here and there that might pique your interest. So thank you very much, everyone.
All right.
Yeah. Okay.